Let's talk about section 10.3, page 504, exercise 15, which reads, use the remainder estimation theorem, or theorem 4, to prove that the Maclaurin series for the function converges for all real x. And for exercise 15, our function is cosine x. Now, one of the consequences of the remainder estimation theorem, or theorem 4, is that if the n plus first derivative of f of t, if the absolute value of that is less than or equal to m times r to the n plus 1, then the series is going to converge to f of x. So that's saying that if this absolute value term over here is less than or equal to some number, an actual number, then the series is going to converge. So we want to show that for our f of t, which is equal to cosine t. Now, we know that no matter how many times we take the derivative of cosine t, the n to the n plus 1 to the first derivative, for instance, we're going to get either sine or cosine. And we know that sine or cosine have an upper bound. So the absolute value of sine t or the absolute value of cosine t are both going to be less than or equal to 1. Sine and cosine have maximum values of 1 and minimum values of -1. So if we take the absolute value of those functions, we're going to get something that's less than or equal to 1. Now this is an upper bound, which means that we can let m be equal to 1. We're going to let r be equal to 1 as well because we're taking the cosine of t. If there had been some kind of a constant in front of that, a factor that we would pick up using the chain rule every time we took the derivative, r would have to have a different value. But in this case, r is equal to 1. So we can say that if we take the absolute value of the n plus 1th derivative of cosine t, which is how I'm going to write that right there, that's going to be less than or equal to m, which is 1, times r to the n plus first power, which is still going to be equal to 1. And because that is equal to an actual number, we're going to be able to say that the series converges. The Maclaurin series for cosine x is going to converge to cosine x. Now let's look for a minute at exercise 17, which is just a little bit different. Here, our f of t is going to be equal to cosine 8t. Now I can still say that that upper bound that I'm going to have for capital M is still going to be equal to 1 because I'm still dealing with a cosine function or a sine function. And when I take the absolute value of a sine function or a cosine function, I have to get something that's less than or equal to 1. But this time, my t is multiplied by an 8. So when I use the chain rule, every time I take the derivative of that trig function, I'm going to pick up a factor of 8. So my r is going to be equal to 8. But when I take the absolute value, and again, I'm going to be taking the n plus first derivative of cosine 8t, and I'm going to take the absolute value of that, that is going to be less than or equal to m, which is 1, times 8 to the n plus 1. And again, because this is equal to an actual number, I'm going to be able to say that the series converges to cosine 8x.